Assalamu alaikum, dear students. Let's start with our lecture number 19 today, which is chapter number 3, transport layer. It is the next layer in the TCP/IP model under the application layer. Okay, so our messages starts from the transport layer when an application layer when a user sitting on a computer using any application program wants to send any message, okay, exchange between the two computers. It starts from the application layer, then it comes down to the second layer, next layer, which is the transport layer on the TCP/IP stack. Okay, so this is the second layer in the TCP/IP model. If we start from top down approach, okay, from application comes down to the transport layer. So our message, okay, starts from the application layer and then it comes down to the transport layer, second layer. Okay, let's have a look on our goals, which we will be studying in this lecture, in this chapter. Understand the principles behind the transport layer, okay, services. What are the services which the transport layer will provide? Multiplexing, demultiplexing, okay, multiplexing the data of multiple processes onto one transport layer or another transport layer protocol, TCP or UDP. Reliable data transfer is the service which is provided by this layer, okay, flow control and the congestion control. We will learn about transport layer protocols in the internet, okay. For example, it has two protocols here. We will study the major two protocols, UDP and TCP. UDP is connectionless, okay, transport layer protocol, whereas TCP is connection oriented transport layer protocol, and TCP is also handling the congestion on the internet. Okay, let's start with today's lecture with our topic, transport layer services. What are the services which are being provided by the transport layer? Okay, this is the outline of this chapter. What are the services which are provided by the transport layer, and what protocols are there which are going to provide us these services? So transport layer basically acts as a layer which is going to transport our application layer messages to the next computer. From our computer, from the source computer, if we want to send something, some message, so the transport layer basic service is to provide the service of the transporting the messages from the source computer to the destination computer, to the other computer, other host. Now that service can be reliable or unreliable. There are some factors keeping in mind or keeping in view. We do need the reliable service, and there are some factors, if we keep in mind, sometimes we do need the unreliable service. But the other benefit of unreliable service is this, that we need best effort delivery, quick service, quick delivery of the messages. Some messages are more concerned about being delivered quickly as compared to be delivered reliably, but some messages are more concerned about to be delivered reliably as compared to be delivered more quickly. If they are delivered a little bit late, it will not make a big difference, but they have to be delivered reliably. Whereas if we look on the other aspect of quick delivery, so definitely quick delivery will involve less overhead, and we can't add more reliability in quick delivery method. So there are two methods basically. One is reliable delivery, which is little bit slow delivery because there are more overhead in delivering message reliably, okay. And the second method is quick delivery, which is unreliable delivery. Why? Because there are less overhead in making the delivery unreliably, okay. But if we want to make the delivery reliably, definitely we have to add more overheads. So that is why two protocols are there. One is TCP, one is UDP on the transport layer. Okay, TCP provide the reliable delivery. Okay, whereas UDP provide the quick delivery. Okay. So transport layer basically provide a logical communication between the application processes. You know that on the application layer you have the programs, the application programs running on the application layer, the topmost layer. So for every application program at the back end, one process will be running, application process. I have shown you the processes here. If you look here, if you open the task manager and Windows Task Manager and click on the icon, these are the applications running here. If you click on the processes, you can see here 63 processes are running right now. If you want to look and if you want to go and check the specific process running for this PowerPoint slide, you can just click on this one and go to the process. It will take you the process power pnt.exe. This is the particular process for this particular application. Okay, so for every application, okay, there is one process which is running. Okay, so these are the processes which are running here, okay, corresponding to some of these applications, and rest of the processes, if you sort the processes here, you can look that how many are the user processes, how many are the system processes. These are the user processes which this user has initiated. Some of the show processes from all the users. Okay, so you can have a look in this way on the processes. Okay, see, some are the local services. Okay, some are the network service processes. Okay, some are the system processes. All the 64 processes are shown here now. These are the system processes, these are the network service processes, these are the local service processes, these are the processes which are run by this particular user. Okay, so these all are basically the processes running on this computer, but for these particular applications, for example PowerPoint or for this Internet Explorer, this particular process is running. So on application layer, for every application there is one corresponding process running on the application layer. Clear? That you can see from here, that a user using a device in his car, the mobile user, he wants to basically communicate with this server. Now there should be, definitely there will be a physical connection between these two users, which will not be a direct physical connection, indirect physical connection. Okay, which will be from node to node. Okay, from this node to its tower, from its tower to its router, from this router to this router. This is a node to node, 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 node to node connection. So this is on the data link layer. Okay, a physical connection. Okay, and data link there, this is a physical connection, wireless physical connection, wired physical connection, wired, these all are the wired connection. Okay, so the wired connections, these are, or either the wireless connections, these are the physical connections between different nodes. Okay, this is the topology, and according to this topology there are different hops involved in between this mobile user and this server. But this mobile user can reach to this server physically by having so many node to node connections. So these node to node connections are being taken care of at the data link layer, the second layer, physical layer, data link layer. Okay, on top of the data link layer we will have the network layer. On the network layer it will deal with the IP address of this node, with the IP address of this router, this interface IP, this interface, this interface, this interface, this interface, this interface, every interface of the router, and every host over the internet will have an IP address. Without the IP address you can't recognize a host over the internet. So the network layer basically deals with the host to host logical connection, whereas the transport layer on top of the network layer is going to deal with the logical end-to-end transport layer connection between the processes of the applications. Look here, this is a process. An application will be running here on the client end, client side application, and an application will also be running here on the server and server side application. So for this application there will be a process running here, and for this client application there will be a definitely process running over here on this client side, and a process will be running here on the server application for the server side process. Clear? So these two processes have to communicate with each other. So that logical end-to-end transport layer connection is provided by the transport layer. Okay? Transport protocol run in end systems, and the protocols which are providing these logical connections between the processes of the transport layers are being provided or handled by the transport layer protocols which are run on the end systems. So TCP or UDP are running here on this and this system. Clear? Whereas the IP is being on every intermediary hop is being running, and even the Ethernet protocol is being run on each and every node. Clear? Sender side will break up the application message into segments and passes the message to the network layer. Whatever message you are typing here, for example in the Skype or in the MSN Messenger you have typed, it is using an MSN Messenger and it is communicating, for example, with this server in order to verify its username and password. So definitely it will provide a username and password, and the authentication will be provided by the Skype server in the first phase. Okay, so the sender side will break up the application message and send it to the passes this application layer message to the transport layer. The job of the transport layer is to break up this message into segments. Whatever message application layer process will get from the user, it will pass on that message to the transport layer. The job of the transport layer is to break up this message into segments, because a very large message can't be transported as it is on the network. It has to be given a shape, it has to be given a fixed length, and that's the job of the transport layer, to divide a very long message into a specific size of chunks. Okay, and those are called the segments. Okay, divide the message into segments, break up the message into segments, and pass on each segment to the network layer. Pass on each segment to the network layer. But before passing the segment, what the transport layer will do, it will break up the message into segments. With every segment, the transport layer will attach an header, and that header will contain the segment number, sequence number. Clear? And inside that it will put the source port number and the destination port number. Clear? Then it will pass on the segment to the next layer, network layer. Clear? Have you seen the NetSeal animation? Animation number 28 OSI model? No? I think you should remember whatever we have done in the class. You are not remembering it, I think. In the beginning I have shown you one animation. You forget it, I think. www.net-seal.net. NetSeal, teaching computer networks through simulation, experiments and animation library. How many of you do remember? Click on the animation. Click here to view the animation of computer networking concepts. 30 concepts are being animated here from the computer networks area, from this subject. Okay. There is an animation number 28, the OSI model animation. Just click on this animation it will ask you to start the animation. What is OSI model? The Open System Interconnection. OSI is a general blueprint that guides the understanding and design of the computer network, how the computer networks are designed and what are their understanding. It partitions the network functionality basically into 7 theoretical layers. The layering approach results in a more modular computer network design. What are the benefits of the layering? That a big problem can be divided into smaller sub-problems, making it modular, and it will be easier to solve the sub-problems, rather as if you dig into a big problem and you want to get its solution, it is better you divide the big problem into smaller problems and then try to find out the solution of each individual sub-problem. Divide and conquer. Okay. And the second major advantage is the modification in each of the layer will become easier without disturbing the functionality of the other layer. But if you have to operate a very big dinosaur, you have to operate it as a whole. But if you have divided a big dinosaur into small teeny birds, okay, which are the individual problems, and if you want to operate any teeny bird, you can operate it individually as compared to a big dinosaur. So big dinosaur is like a very big problem, and small teeny birds are the smaller problem. So it is easier to handle a smaller problem individually as compared to a very big dinosaur. What is easier to have in your home, dinosaur or a small birds? Small bird. So that is why we are having multiple layers here as compared to have a very big layer. Okay, single layer. Single big problem we can't afford as compared to the smaller problems, okay, are more easier to solve as compared to one big complex problem. Clear? So it decomposes it into more manageable components, the individual teeny birds. Okay, this is the title of your operating system book, Silbershare, operating system concept. There is a very big dinosaur and a small teeny birds. Okay, the old operating systems, their kernel were very monolithic, heavy, fat. But now the new operating system, their kernels are smart kernels. Okay. The animation explains the OSI model as well as the relation to the internet architecture. Start the animation. It will ask you to give a username and password. You can register here. Click here to register. You should have a username and password in order to get into this website. Okay. Once you have your username and password, then you can run this animation. Okay. Have you remembered now something? Yes, in the lab we have done already this. We have run already this animation, but no problem. I am going to again run this animation. Can you please close the light this side? I am again going to run this animation so that you can get a better understanding of this. In this animation, we will discuss the open system interconnect OSI model. And you know that there is a difference between OSI and TCP/IP model. OSI model is a 7-layer model, theoretical model, whereas TCP/IP is a 5-layer practical model. OSI is a theoretical model, open system interconnection, written in the book, explaining you the functionality of all the 7 layers, whereas the TCP/IP model is a practical model on which the internet is based, and it is a 5-layer model. In some books it is written 4 layers, in some books it is written 5 layers. If you combine the last 2 layers, physical and data link layer, it will become a single layer and it will become a 4-layer model. Okay, if you keep those lowest most 2 layers separate it will become a 5-layer model. Okay. So in this animation we will discuss the Open System Interconnect OSI model. It is a description of how computers and processes can communicate over a network. The OSI model is not currently an implementation, it is theoretical model, but rather a theoretical model. The TCP/IP model is widely implemented. We will compare these two models at the end. At the end of this animation we will give a comparison of both the models, okay? But let's start with it. This is the 7-layer model. I have given you a sentence, I quoted you a sentence. Please do not throw Salman's pizza away. If you remember this sentence, it will be very easy for you to remember the name of these layers. Otherwise, it will be difficult for you to remember the name of these layers, or even if you can remember, you might there are chances that you disturb the order of the layers. You have to keep these layers in order, biltartib. Okay, physical, starting from the lowest most where the computer is physically connected. Data link layer, network layer, transport layer, session layer, presentation layer, application layer. To remember it, please do not throw Salman's pizza away. If you remember this sentence and take the first character of every word, it will exactly give you these 7 layers, starting from the down, bottom up approach, down to top, bottom to top. Clear? Now the OSI model has 7 separate layers. Okay, we will explain each layer using an example. If you start from the application layer, okay, so application will have a direct correspondence with the application on the receiving side. Sender side with the receiving side. This is the sender side. This is the receiving side. Presentation will have a direct correspondence with the sender and receiver side, session and transport. But here the network layer is having a immediate correspondence with the network devices because it has to deal with the IP addresses. It has to deal with the port numbers defined in the applications. Here it has to deal with the IP addresses for the interfaces of the devices. That is why it will deal from host IPs. It will deal with the host IPs. But it has to also deal with the direct link, node to node delivery. So MAC address of this computer and MAC address of this computer, because both the devices are on the same network. So this delivery will be a direct delivery between the two nodes, and this delivery will be done on the MAC addresses. Clear? And then the physical, this is the physical link between these two nodes. This is the physical link between these two nodes. This delivery will be on the physical addresses or MAC addresses, and definitely they will have the layer 3 address, layer 2 address, layer 3 address. Layer 3 address the IP address, layer 2 address the MAC address, the physical address, hardware address. Yeah? Pardon? Yeah, MAC address. Here is the MAC, here is the MAC, here is the MAC, here is the IP. Layer 3. Because this is a layer 3 device, so you have to go till layer 3 for this device. But if it is only a layer 2 device, then you will communicate only on the layer 2 in the LAN. But on the WAN you have to go to till layer 3. But in the LAN, in the Ethernet, you have to communicate only on the MAC addresses. It will be used in the first phase. In order to get the MAC address, you will broadcast on the IP address, but for that IP definitely you will have a broadcast MAC. Okay, so each layer talk to the corresponding layer on the destination node. This happens because each layer appends control information to the data from the layer above, and layer on the other node reads it. We will show an example of the OSI protocol stack in use. The red node will send an email to the server. This red node laptop is going to send an email to this server. Okay, now the email, it will open a email application here. Okay, the mail client software, and it will compose an email in that. Application layer responsibility is provide the interface to the application program, and this interface is provided by a user application or an email user client. In that, it could be Outlook Express, it could be if it is a user agent software, it should be on the user host like Outlook Express. Okay, but if it is a web-based email, you can open the website of that company here, in which you can compose the email. Okay, in using a mail client software. Definitely they will be using some mail client software. Clear? Now email will be composed here, and in the application layer header you will type here the user email, the sender email, and the recipient email. Clear? The destination email address, the recipient, and the sender, you are the sender. It will be, your email will be there in the message from where the email is going to be sent and where it is going to be sent. Who is the recipient? The destination email address. To and from is your address. Okay. Now the application layer uses the SMTP command to tell the server how to handle the data. You use that, you know that here this is a mail message, how it will be known to the underneath layers, because this message will be having a SMTP protocol in it. This message will be transported with the help of the SMTP protocol, which is an application layer protocol. So application layer protocol is going to transport this message and going to send to the server that this message should be transported using the SMTP protocol. Clear? So the application layer uses the SMTP command to tell the server how to handle the data. This email message will come down on the presentation layer, and presentation layer responsibility is convert from system specific format to the network format. Whatever format is understandable by the network, the user like language should be converted into a language which is understandable by the network, and it provides also the encryption and the compression facility. The presentation converts the text to the ASCII format and specifies the format of the image, whatever images you are going to transport. Okay, then it comes down to the session layer. Every layer is going to add an header. When it came down to the presentation layer added a header here, which was the header of the presentation layer, and whatever presentation layer has done, it has put that information into this presentation layer header. When the presentation layer data will come down to the session layer will put an header here, and it will whatever functions the session layer will take on this message, it will write those here inside the session layer header. Session layer responsibility facilitates the starting, handling, and ending of the connection between the nodes. Synchronize related stream of data like video and audio stream for a video session. Adds a header to handle the session. So how many sessions for video, audio, for data, there will be different sessions. So it will allocate a specific number to every session, that it will handle the communication of every session individually. Then the session layer message will come down on the transport layer. Okay, and the transport layer responsibility is to provide the reliability, because it is an application layer message which is being transported with the help of SMTP protocol, simple mail transfer protocol. And simple mail transfer protocol is a protocol for the email transportation, and it requires a reliable delivery. That is why SMTP will be transported through the TCP protocol on the transport layer. As I specified you that on the transport layer we have two type of cars. One is the UDP car, one is the TCP car. UDP car is the unreliable car, wherever TCP car is the reliable car. So those passengers who do need reliability, they will definitely sit in the sedan car, reliable car. Whereas those passengers who are who are in hurry and they want to reach to the destination very quickly, they have to sit in the unreliable car, which is the sports car. But with the sports car, we are not guaranteed. With the sports car, anything could happen on the way. It might face some problems, okay, or an accident could happen with that car, because it is an unreliable car. It will go very fast. So there is no reliability of the passengers who are going to sit in the sports car, whereas the passengers who are going to sit in the sedan car, as compared to the sports car, it is more reliable, because it will go slowly, it will stop over, it will take the stopovers, and it will have some safety instructions, okay, it will try to take care of the packets. Yes, please.
Victor, where is encryption? Which layer?
On the presentation layer.
Presentation layer to session.
Yeah. Okay. Then this transport layer, that is why I said that it will deal with the reliability in case of the TCP protocol, because the email is going to be transported on the TCP, is going to use the services of the TCP protocol on the transport layer. That is why we call it reliability. It is reliable protocol. It provides us the flow control. Also, it provides us the fragmentation. It provides us the port numbers, okay, which are used to differentiate between the different application processes running on the same node. The transport layer uses the TCP in this example. Why? Because it is going to transport the email, okay. Data is broken into segments that are reassembled by the transport layer at the peer on the destination. It is going to segment the data and attach a header, segment header. In the segment header, it is going to write the segment number or sequence number, and the source port number and the destination port number, and multiple segments. These different for example, 4 segments are going to be transported from here to this server. When the segments will reach on the server, the segments will wait here on the transport layer of this server in order to arrive all the 4 segments, and then the message will be completed and the message will be sent to the upper layer, application layer. Otherwise, half of the email can't be sent to the application layer. It has to be a complete email. In order to complete the email, the transport layer on the receiver has to wait unless until all the segments will arrive. Yes, please. Yeah. Definitely. Because this is the job of the transport layer, to break a big message, large message into smaller segments and transport the segments, because its job is to transport the segment. Okay. So each segment is sent to the network layer. The source and the destination port numbers are also specified in the segment header. Clear? Now each segment will come down to the network layer. Network layer will attach its own corresponding header, the header of the network layer. Each layer is attaching a header. So attaching of these header is called the encapsulation on the sender side. When the PDUs will be received here, each corresponding layer will remove the header. So it will do the process of reverse of this encapsulation, which is called the de-encapsulation on the receiving side. De-encapsulation. The sender side will do the encapsulation. Encapsulation means each layer will provide its corresponding functionality and will attach a header with the message and send the PDU, protocol data unit, to the next layer, the message to the next layer, and next layer will provide its functionality and attach its corresponding header and send it to the layer below it. So in terms of this, you could say that each layer is giving a service to the layer below it, or each layer is going to be served the layer above it. Clear? So what the network layer will do with the segment, it will encapsulate the segment into a packet. responsibility is provide addressing across the internet. Now the internet addresses are the layer 3 addresses, the IP addresses, and these addresses are on the network layer. Clear? So used for the routing purposes, determining which path the data will take. The network layer here is using the IP. The segment becomes a packet while the segment is encapsulated into a packet. What is this encapsulation? Just attaching an header. Nothing more than that. Okay. By adding a source and the destination IP address into the header of that packet, packets are sent to the data link layer below it. Now the data link layer is attaching a header and a trailer. Header will indicate the start of the frame and the trailer will indicate the end of the frame. Now this packet has become a frame here just by adding these header. So responsibility reliable transfer between the two nodes. Okay, node to node delivery. The network layer handles the host to host delivery, and the transport layer handles the process running on the client computer and the process running on the server computer. The packet, this layer, and trailer. Trailer is indicating the end of the frame. Reliable data transfer between the two nodes. Physical addresses are added here. This is the physical address on the data link layer. This is the IP address on the network layer. This is the port number on the transport layer. The packet becomes a frame now after this encapsulation, adding the header and the trailer, that are created for the specific network, because this media is Ethernet LAN, this media is ATM WAN, this media is Ethernet LAN. Every different type of the media will have its corresponding type of the frame, and that is the responsibility of the data link layer between these two nodes, because they have compromised, they have agreed upon this physical network, which is the Ethernet LAN. Specific network Ethernet here in this example. The frame have the physical addresses of the two nodes. The data is traveling between this node and this node. This is the physical address for this, and this is the physical address for this. Then the packet comes down on the physical layer. The physical layer puts the bits. It will divide this packet into bits, and the bits are going to be put on the wire in form of electrical signals, if it is a copper wire. If it is optical fiber, in the form of light pulses. If it is a wireless media, in the form of electromagnetic waves. Clear? Yeah, I'm going to stop, please. The physical layer puts the bits on the physical medium given to it by the data link layer. Okay. Then go next. The bits will go to the router. Here the router must send the frame over the different network with a different data link protocol. Here the protocol was Ethernet protocol. Here the protocol is different, ATM WAN, cell switching over the different network with a different data link protocol. Only the data link layer and the physical layer requires the modification here. Physical and data link layer. There is no change on the network layer. It will take the bits, okay, on this interface, combine the bits, combine a frame and send it to the data link layer. The data link layer will look into the destination MAC address. If the destination MAC address is same, it means this frame is destined for this router. Okay, the router removes the data link information and send it up to the network layer. Okay, on the network layer, the router will look the destination IP address in the IP header. If the destination IP address is not for this, it will forward it to the other interface by looking into its routing table, that how it can send the packet, where it has to forward the packet so that it could reach to the destination. The router uses the destination IP address to determine where to send the packet next so that it can reach to the destination. It will again do the encapsulation. Packet will be encapsulated into the frame. and the frame is going to be sent on to the physical link in terms of bits. The router encapsulates the data with the proper data link layer information for the ATM WAN now. Now look here, the encapsulation was for the Ethernet, here the encapsulation is for the ATM. The encapsulation is changed because this router is connected with two different type of medias, two different type of physical networks. On this side with the Ethernet, on this side with the ATM. So it will be the responsibility of the data link layer to put the data into the corresponding type of the frame according to the type of the physical network. Ethernet frame or ATM cells. Clear? The frame will be divided into bits and bits are transported over the router. Here the packet is dropped basically. The packet was lost because the router was congested. There was more traffic here. The sender transport layer will time out and it will send to the send a message to the not acknowledge message to the receiver transport layer will time out and it will ask the sender transport layer again to send the packet again. The sender transport layer timed out, sender transport layer is timed out, waiting for an acknowledgement from the receiver, and the acknowledgement has not come yet from the receiver. That is why the sender transport layer is time out and it is going from the receiver transport layer. The sender transport layer will retransmit the data again because it did not receive a specific reply from the receiver in a specific time. Now it is received here on this router. The router removes the data link information and send the packet up to the network layer. Okay, network layer will check the destination IP address again. The router uses the IP address from the network layer header to determine where to send the packet. It found that it has to send the packet to this interface so that it could reach to the network. Okay, once it determines the next hop, it appends the appropriate data. It appends the appropriate data link information to send it onto the network, on the Ethernet network again. Okay, again the packet is dropped here on the server. Some data link layer protocol provide reliable communication between two nodes. In this example, the Ethernet data link layer does that job. When the sending layer does not receive an acknowledgement from the receiving layer, it resends the frame again. Okay, look here from here, because it did not receive an acknowledgement here from the data link layer of the receiver. Each layer of the model now removes the layer of the encapsulation and read the information appended by the same layer on the sender. Look here, this is the email received on the physical layer of the receiver. I am going to stop here. In the next lecture we will continue from here. Okay, thank you.